A clutch is basically a friction material, sort of like a brake pad that transfers the power between the motor and the transmission, which ultimately goes to the wheels. You have a flywheel on the end of the motor, at the end of the crankshaft, which is in the bell housing of the transmission, and you have a clutch disc that bolts up to the flywheel. Then you have your pressure plate that holds the disc in place. So now you have the flywheel that's bolted up to the motor that's constantly spinning. Then you have the pressure plate that bolts up to the flywheel that holds the disc in place. And the disc is splined. The spline's right here in the middle of the disc that'll go onto the input shaft of the transmission. So the clutch spins freely in the middle, and every time you let in and out of the clutch pedal, the pressure plate moves back and forth to engage the disc to the flywheel. Friction eventually will stop the disc from turning, and the pressure plate will transfer the power from the flywheel to the splined input shaft through the transmission, which ultimately hits the ground. As you can see, the flywheel gets bolted onto the crankshaft with bolts, and it is stationary with the crankshaft now. Take the clutch disc, and you stick the alignment tool through the center of the clutch disc, and in through the center of the crankshaft. Then you line up the pressure plate onto the dowel pins. You can go ahead and start putting your bolts in. That's the actual motor. This is the end of the crankshaft opposite the timing belt. This will be covered up by the bell housing of the transmission. So now we're in the hole. We need to line it up. And there we go. And that's basically an install of a clutch.
When the clutch disc is locked to the flywheel, the engine's power is transferred to the transmission input shaft. The power flows through the input shaft and input gear to the counter shaft.
on an automatic car, when you're accelerating and revving engine higher and higher, even though the output isn't turning or it's turning slowly, torque is being built up in there and trying to break the wheels free or get you to move. So energy isn't wasted, but some heat is created, and there is actually some energy lost. Now, most torque converters in almost every vehicle work the same. The difference is there's lock-up torque converters which have a clutch inside, so when the thing gets spinning at the right speed, and the input and output when you're driving along are almost the same speed and your vehicle is traveling at usually more than 45 kilometers an hour, the clutch grips together. It's controlled electronically, but it works hydraulically, and that causes the input and output to spin at the same speed. Normally when you're driving along in an automatic car, the torque converter is always around 10% inefficient. So there's 10% less RPMs coming out the back end than are being driven by the flywheel. That always is creating a little bit of heat, and that's why automatic transmission cars have a transmission cooler. Automatic transmission cars that have the lock-up torque converter, which most modern vehicles do, get about the same fuel economy on the highway as a standard car, but not in the city. So let's see what's inside. Looks like a grapefruit almost. At least an orange or a grapefruit when you cut one in half. So there's all the parts of your torque converter. This first one is the side that goes into your transmission. This part sits in there. There's the side that gets driven by your flywheel. And a little oil. And there's the other side, which looks exactly the same as that side. And on the back is a clutch plate and disc. So this one has the lock-up torque converter to give it better efficiency when it's driving at normal speeds on the open road. So how it works is it's really just a centrifugal pump. Looks like a vacuum cleaner inside. Oil is pumped in through the main hole in the middle from the valley of the oil pan of the transmission. And it keeps getting thrown into the middle until the torque converter is completely filled. And the oil that's in these veins, when it's spinning, centrifugal force throws it out. But it throws it out in a way that it wants to come out like this, on an angle. Well, when it comes out like that at an angle, it hits these opposite veins, which have a greater curve on them, and it induces this thing to want to spin at the same speed as that. Every action has an opposite and equal reaction. And that's what drives your car. So all the time the engine is running and your foot's on the brake and your car's not moving, this thing's throwing oil at not that great of speed. So the oil is sort of getting all chopped in half and not actually pushing this thing around, but it is applying force against it. As this thing picks up velocity, the oil is getting thrown out with great more centrifugal force, and it starts to flow in a pattern like this, completely in circular pattern, to those veins in the middle, and creates a vortex all the way around. Well, that causes this thing to start to work a lot more efficiently, and they end up spinning pretty close to the same speed, input as output. Of course, there's friction between the oil flying around with all those moving parts, and that's what's creating the heat in your transmission. So a torque converter is basically just a hydraulic clutch. So it's kind of easy to understand, I guess.
This is a differential that's present in the rear end of every vehicle. The drive shaft comes in from this direction, from the transmission. On the end of the drive shaft is a small pinion bevel gear that meshes with a larger ring bevel gear that's mounted to this flange. This whole assembly is inside of another casing, and it's well lubricated. So when the drive shaft turns, it causes this whole assembly to rotate. And each end of this assembly is where the rear axles exit, providing power to each rear wheel. So normally, if this is rotating together, both wheels would rotate at the same rate. But the purpose of a differential is to allow differential motion between the axles. So the axles can turn at different rates. And that's provided by this planetary bevel gear drive inside of this assembly. So you can have relative motion between the shafts. And I'm moving them right now, so one is moving relative to the other. This is a GM Positrack that has extra features in it that help limit the amount of slip or relative motion you can get between wheels. And that's accomplished through a set of clutches and centrifugal masses. These centrifugal masses or pivot out as rotational speeds increase. This particular mass pivots out as the whole assembly rotates. There's masses on this smaller shaft here that also pivot out. They only pivot as you get relative motion between the shafts. And if you get too much relative motion at certain speeds, these two masses lock, causing the two rear axles to be locked together and turning together.